Hello, everyone. Welcome to the RCNP. And in this part, we're going to introduce the technical principles and application of IP source cards, or we call it IPST. The following scenarios happen frequently during the OM process of a campus network. For example, an invalid DHCP server exists on the network, which assigns incorrect IP address and gateways to STAs. As a result, many STAs cannot access the network. Or in a DCP environment, IP addresses are manually configured for some STAs, resulting in confused IP addresses and even network exceptions. So to solve these problems, we can use IP source card, and let's see it. IP address conflicts in a LAN bring difficulties in network OM, and the network showing in the figure on the right has the following risks. Let's firstly take a look at this figure. We have two PCs, right? And you can see the IP address of them. For the PC1, the IP is 172.16.1.1, and the PC2 is 1.2. There is a web server which IP address is 1.200, and the core switch in the network act as the DHCP server, and its own IP is 172.16.1.254. And then let's see the risks. PC1 discards the IP address assigned by the DHCP server, use the manually configured IP address to access the network. If the manually configured IP address is 172.16.1.254 or 1.200, the network is abnormal because there would be a conflict IP address exist on the network. And PC2 fakes multiple IP addresses to initiate a scanning attack, which causes IP address conflicts of numerous STAs, and the STAs cannot access the network anymore. So to solve these problems or to handle these risks, IP source card is provided. It detects the source IP address of the source IP address and source MAC in packets, only transmits valid packets. So in this way, if we manually configure an illegal IP address for a PC, or when the PC fakes IP addresses to initiate the attack, IP source card can block these packets. Okay, so to use the IP source card, we can maybe handle these risks. And but the key points when we use it is that check baseline and filtering rules. Okay, and so what is the baseline? What's the filtering rules? Let's see it. When we use the IP source cards, actually we can use some parameters from DHCP snooping. DHCP snooping entries record the MAC address, IP address, VLAN ID, and interface information, which you can see in this figure. By using the command show IP DHCP snooping binding, you can see the MAC address, the related IP, the type, VLAN, and interface. It provides source data for data packet filtering. That is the check baseline. Data packet filtering rules are configured on ports. So here we have got the baseline, which is the entries from DHCP snooping. What the rules is manually configured, and let's see it. Interface range gigabit Ethernet 0, 10 to 11. IP verify source. So here, actually, this is a rule. So to verify the packet, we should check some of the parameters. So what's the parameter we should check? We can check the VLAN, the port security, or this is enter. Enter, let's see the difference between them. If you set it to be exclude VLAN, means VLAN within which IP packets are not controlled by IP source card. Or if you use port security, the IP address and MAC address in data packets are checked. If you just enter, it means IP only. IP only references that only the IP address in data packets is checked. And data packets from STAs with a previously configured IP will be discarded because since it's previously configured, so if you check the DHCP snooping binding table, there will not be an entry which is related to this IP. So since the DHCP snooping entries are the baseline, so it will not match any entries and it will be discarded. Okay, this is about the how to use the DHCP snooping as a baseline and how to configure the filtering rules. And except the entries from DHCP snooping, we can also add some static binding entries. The configuration is shown here. Manually configure the static entry binding mode in global configuration mode. Pay attention here. These commands are used in global configuration mode and add source data of IP source card. As you can see here, we have added some entries. IP source binding. This is the MAC address. VLAN 1, this is a VLAN. This is IP address. This is the interface, right? So by using this command, we are adding the interface and IP binding modes, or IP source binding, MAC address, VLAN, IP MAC means we are adding the IP address and MAC address binding modes. Next, IP source binding, MAC address, VLAN, IP only. From here, you can know IP only means add the IP address only binding mode. After having these entries, next is enable IP verify source on the interface, right? And when you enable the IP verify source, there could be some different modes. For example, IP address only or IP address plus MAC address. During the configuration here, you can see some suggestions. Because here, we should manually configure some binding modes, right? Static entries, and you are selecting maybe different modes, IP address only, IP address and MAC, or interface and IP. But when you enable the IP verify source, it's configured on the interface, right? So the mode you choose will actually affect the result. For example, let's see. The global binding mode must be consistent with the port filtering rules. If source data is added based on the global IP and MAC, the port needs to filter data based on the IP address and MAC address. If the global binding mode and the port filtering rules are inconsistent, the global configuration prevails. For example, here is a list. From the list, I think you can understand it. For example, you can see global interface and IP. While if on the interface, what you configure is interface IP address only. So the last result will be only IP address or IP address only. And global interface and IP, or while on the interface is interface IP and the MAC. So it will also be IP address only. Okay, and if at the global configuration mode, what you said is the IP and MAC, and on the interface is IP address only. So it will take the IP and MAC address. For the second mode is the same, IP and MAC. While if you globally set it to be the IP address only, and no matter what you configure on the interface, it will be IP address only. So based on the modes you like, you should take both global configuration and interface configuration into consideration. Right? Okay, and next, let's see. After finishing the configuration, what we should do is to check, right, to check the result. So to check the results, here is showing us two commands. Run the show IP source binding command to display the source data of IP source card. As you can see here, show IP source binding, and you can see here are two entries: the MAC IP and the VLAN, the interface. Okay, and next, run the show IP verify source to display the ports with IP source card enabled and their detection types. You can see we have enabled it on both G01, right? And it's IP MAC. The filter mode is active, and the IP address is 172.16.101. The MAC address is here, and the VLAN is 1. While you can see, why do we have another entry on the same interface? It means that except the package can match the first entry, all the others will be denied. So this is the reason why we have two entries for one interface. Okay, this is about how to check, how to verify. And before you use the IP source card, here are some precautions. When IP source card is enabled, IP packet forwarding may be affected. In general, IP source card is used together with DHCP snooping. The configuration sequence of IP source card and DHCP snooping is not delimited. IP source card cannot be configured on the trust ports of DHCP snooping, and cannot be configured on the excluded ports of global IP address and MAC address binary entries. On a weird network, IP source card can only be configured on switching ports, layer 2 aggregate ports, and layer 2 encapsulated sub-interfaces, cannot be configured on layer 3 interfaces. So about the IP source cards, here's a working principle, the application scenario, the configuration over it. And about this part, let's see a summary. DHCP snooping snoops DHCP ACK packets and extract the IP address, MAC address in the package to form DHCP snooping entries. The DHCP snooping entries are sources from data packet filtering of IP source cards. Data packets that do not match DHCP snooping entries will be discarded. Solves the problem of the previously configured IP address in a DHCP environment. You can manually bind static entries of IP source cards to add source for data packet filtering. The manually configured entries are displayed in the static modes in the source state table of IP source cards. The manual binding mode provides a whitelist for previously configured IP addresses in a DHCP environment. That is, packets for previously configured IP addresses can be allowed to pass through the static bindings. Because we said that the main problem that the previously configured IP cannot work or cannot access the network is that it's manually configured. So there is no entries can match these packets in the DHCP snooping binding table. So it will maybe cause this problem. And to solve this problem, we can manually add some static entries to match these packets. Okay, about these parts, then let's see a question. In IP source card configuration, if the global binding rule is IP and MAC, the filtering rule on a port is IP address only. The effective filtering rule is IP and MAC address. You think this statement is true or false? Actually, it's true, right? It's true because in the slide there is a table showing us this answer, right? It's true. It's important. You should remember this. Okay, that's all for this part. Thanks for your listening.